Yes. Hey everyone, we had some technical difficulties, but we should be good to go now. So just send me a message in the chat if you can hear me loud and clear. And I'll just give people a couple of minutes to get settled in, find the new stream link before we get started. Oh, glad to hear that you guys can hear me. So for those of you who are here right away, if you haven't installed Git, make sure you go and do that right now, because this is going to be an interactive tutorial. So if you have Git installed to follow along with, then that'll be super helpful and you'll learn a bunch more. So real quick as well, if you guys want the link to these slides, you can check out this tiny.cc link, and that will give you a link to everything we're going to go over in the presentation. So if you learn really quickly and you want to skip ahead, you can do this. If you are having a bit of trouble and want to go back to an old slide and see what we talked about, that'll be super helpful. And then after the workshop, if you want to use this as a reference, you should save the link as well. There'll also be a link to the YouTube recording in here if you want to come back later and watch it. Okay, we're probably going to get started now, and any stragglers who come in later, hopefully you can catch up to us. I'll answer Ariel's question for everyone. Are we going to be using the command line interface or mostly the graphical user interface? I'm going to teach you guys all the command line stuff because I think that if you understand the command line stuff, then you'll be able to use any GUI that you need to. And we'll also go over some basic command line commands so that those of you who've never used the command line before can get familiar. And I promise that by the end of it, you'll be able to use Git in an IDE, in a GUI, in the command line, whatever. So let's get started then. For those of you who don't know me, I'm Felix. I'm the president of SCS this year. I've been teaching the Git tutorial for the last 3 years. This is like my 6th time doing it. Although every time I do it, I learn a few new things about Git, so I'm still not a perfect expert. I've also used Git in my internships and in my projects, so I've been around the block a few times. To give you a quick overview of what we're going to talk about today, first I'm going to make sure you guys all have Git installed and GitHub accounts created, because you're going to need those for the tutorial. This is an interactive tutorial, so it's 100% best if you follow along with me and do the commands with me as I do them, because then you get some hands-on experience. We're going to start the workshop off with a little bit of theory, not too much. And then we're going to do the practical portion where I'm going to walk you guys through a basic use case scenario for Git. And then if we have time at the end, we might cover some bonus topics and then open it up for any questions that you guys might have. At any point in the workshop, feel free to ask any questions in the chat. I have Matthew, who's going to be checking the chat and answering your questions, and I'll also answer them out loud for you. Also, if you can't hear me very well or if I have any background noise, let me know so I can get that settled as quickly as possible. Another quick FAQ, there's going to be a recording uploaded to YouTube automatically when the stream is over. So you can always, if you don't have time to stay for the full thing, or if you want to come back and check something again tomorrow, you can always do that. Don't worry about it. So let's start by the preliminary things. Make sure you all have Git installed. If you go to gitscm.com, you can download Git. It should automatically detect what operating system you have. You can click download. Feel free to settle for all the default settings. You should be fine. I, of course, already have Git installed, so I'm not going to install it again. Whether you're on Windows, Mac, or Linux, it should work fine for you. We've hopefully found all of the OS-specific problems you might run into. Once you have that all installed, you can go to github.com. GitHub is not the same thing as Git. Whereas Git is a program, GitHub is like an online hosting service. So you're going to need an account on GitHub. This is my GitHub profile. Please don't stalk me. Make sure you go here, and if you're not signed in, you should have the option to create an account and set it up however you want, set up with your email. I already have an account. I'm not going to create a new one. Feel free to follow me if you want to, but that's a little bit weird. Don't stalk my code. You're going to need an account for the tutorial though, so make sure that you create one of those. You downloaded GitHub Desktop. That's okay. You can use GitHub Desktop, but for this workshop, like I said, we're going to do everything in the terminal. I don't know if the GitHub Desktop download includes the terminal version as well. So when we get to that step, just make sure that you can use it in the terminal. Otherwise, it's going to be a bit hard to follow along. But it works the same way. It's just instead of typing in commands, you click buttons. Okay, so hopefully you all have Git installed and GitHub accounts created. If you don't, just try and catch up while we go over some of the theory. So let's start with why. Why learn Git? What even is Git? Why do you care about this workshop? Git is what we call version control. Version control means keeping track of the different versions of your program, saving, being able to go back to old versions, being able to share with other people who are on different versions. In short, Git, it lets multiple people work on the same project together while also saving a complete history of the whole project. Like that, you don't need to save multiple copies, email copies of your code to your friends. You don't have to worry about deleting something and then needing to use it later. It also provides tools where you can merge files together. So if you and your friend worked on the same code file and you want to merge your changes together, it's super easy, and also helps you resolve conflicts when two people have changed the same thing. Should you download Git from the site you gave us? Yeah, I would recommend re-downloading it from there if you can. I don't know if the UI lets you, but if you want to double check, when we get to this spot where we're using the terminal, you'll be able to see if you have the right stuff installed. Yeah, so Git, it lets you, mostly it's used for working together, although I have used Git for a lot of solo projects just for the saving and going back to old versions. You're 100% going to use Git during your team projects at Concordia or any other university you might be going to. You're 1,000% going to use it at your job if you're doing programming. Every single company that does tech on the entire planet uses Git or something like Git, such as Mercurial or Subversion. Git is the most popular one, though, and they all work the same way under the hood. You'll use it for individual projects too, if you're smart. Saving your code, backing up your code, it's all incredibly useful. So the main reason you want to learn Git is, I guess, the jobs and team projects part, but I promise you if you're doing programming, you're going to use it. Technically, you're supposed to learn this at Concordia if you're in software engineering, at least. I'm in software engineering, so I don't know if you guys take the 341 class. But when I took the class where we were supposed to learn Git, the teacher spent like half a lecture and barely really taught us and just expected us to figure it out. So hopefully after today, you'll have a fairly good understanding of how it works, or at least a baseline that you can work off of. So now you know what Git is used for. Now you know why you should learn Git. Let's learn real quick a little bit about how Git works in terms of repositories, branches, and commits. So a repository is a place where you store all the files in your project. It's kind of like a folder-ish thing, or a big folder that stores all your project files. GitHub is a website that will store your Git repository online and let you share it with others. But you can also create repositories locally, and that's what we're going to do later. So the repository is just the place where all your files are. Of course, if you want to do work on multiple things on the same time, you can use branches. So each repository has the master branch, which contains your stable, up-to-date, best version of your project. And then you can create other branches when you want to add a new feature. So think of it like a tree. When you want to add new code, you branch off from master branch, you add changes onto your separate branch, and then when your changes are good, when your feature is done, you can merge that branch back into the master branch, which is supposed to always be stable. If you're working with other people, you might all be on your own branch. So maybe I'm working on one branch on one feature and you're working on a different branch. And as long as we're on different branches, our changes aren't going to conflict with each other and cause problems. Each node on this tree is a commit. When you create a commit, you're like packaging all of your changes into one distinct save state. So committing is a bit like saving, and it packages all your changes into one bundle. Each commit is just like a separate set of changes, and that's how Git will kind of measure your changes. It doesn't constantly save each line of code. You get to pick how you want to bundle them and save them together. That's important because later you can revert commits or merge them together or roll them back and all kinds of funky stuff. We're going to skip this slide for now because it's just confusing and go straight into trying out Git. So now you guys can open, if you're on Windows, Windows doesn't have a built-in bash terminal. So if you installed Git at the link I showed you, you should have Git bash now. So if you click on just your search thing and type Git bash, you should see an app. And if you click on that or press enter, it will open a terminal. And I'm going to zoom mine in so you guys can see what I'm doing. If you're on Linux or Mac, you can just open the regular terminal app by, hopefully you know how to do that, but it's just search, enter terminal, click on it. We've also had issues in the past. If you're on Mac or Linux and your default shell is something other than bash, like ZSH or whatever, just enter the bash command and it will switch your terminal to being a bash terminal. Some people have problems because they're not using a bash terminal, and we're going to be using bash commands. So hopefully you guys have, hopefully you guys have your terminal open now. Mine looks like this. I keep shaking it from side to side, which minimizes my internet window. So if you aren't able to open your terminal, God, I need to stop doing that. Then make sure you have Git installed, and if you're on Linux or Mac and you can't do any of these commands, make sure you type in bash. Okay. In case some of you have never used Unix before, I'm going to tell you a couple of commands. But first, we have a question. What does mingw64 stand for? You're going to see something different here, probably. I don't remember if this is the folder or the user. Honestly, it doesn't really matter at all what's here at the moment. Yeah, I honestly don't actually remember what this means. It's not relevant to the workshop. You probably won't see the same thing as me here. I can tell you that this is my user because I'm the user Felix on, this is the ID of my laptop. You might see something different. It doesn't matter. All right, so again, this is why you should have the slides open because I might cover up what it says sometimes. Let's go over some basic commands for those of you who might not be as comfortable in a terminal. Let's start with ls, which will list the contents of your current directory. I'm in my root folder, so I have all kinds of random crap, like my documents, my app data, other folders. If you want to see exactly where you are, you can do pwd, which stands for Path of Working Directory. I'm in my C drive under my users folder. Using cd, you can change what directory you're in. So I know, because I did ls, that there's my desktop folder in here. So I'm going to go to my desktop, change directory to desktop. And now you'll see this has changed to say desktop because this tells me where I am. The tilde means my user folder and then desktop. Again, let's do ls to list the contents of my desktop. I have all kinds of stuff, a bunch of folders, Minecraft, notes, coding stuff, capstone, algo time crashes, all kinds of folders that I have on my desktop already. You're obviously going to see something different. Again, pwd tells you the path of the working directory. We've moved to C users Felix desktop. If any of these commands don't work for you or you see any errors, just hit us up with a message in the chat and I'll be keeping track of that. Okay, so what we've learned is how to move around, list the contents of the directory, and figure out our current directory. Hopefully you all realize the terminal is just, right now we're just moving around in our folder. It's like File Explorer, but without a user interface, just with commands. And just like in File Explorer, we can make a new directory. So that's with mkdir, which stands for make directory. I'm going to make a Git tutorial folder just to stick all my Git tutorial related things in. I'm going to call it Git tutorial. You should probably call it the same thing, just so you're not confused later. I just made the directory, but I'm still not in it. So if I want to step into that directory, I can use cd for change directory. Git tutorial. And now you've seen that this text here has changed to say I'm now in the Git tutorial folder. If I do ls, I see nothing because this is a new folder and it's still empty. If I do pwd, I see I'm in C, users, Felix, desktop, Git tutorial. Standard. You can also use rmdir to delete a directory. So I can make a new directory called test. You don't have to do this if you don't want to. Now if I do ls to list the contents of my current directory, I see the test folder, but I don't like it, so I'm going to do remove directory, rmdir test, press enter. And now if I list the contents of the current directory again, it's gone. I'd like you guys to tell me in the chat, like if I'm going too slow or too fast. Just let me know really quick so that I can adjust if my speed isn't right. Although obviously if you know this might seem a bit slow to you. Just take a quick pause so you guys can catch up. Okay, let's go over a couple more useful commands. These are all about creating files and writing to files. So first we can do touch to create a new file. So say I want to make a file called test.txt, I can do touch test.txt. And now when I do ls, there's a new file here. Pretty simple. If you want to write to a file, you can use echo. So if I want to write something to my test.txt, I could do echo hello world, a classic, of course. And then put these two little arrows, and then the name of my file, which is test.txt. And now you didn't see anything, but I promise you that just wrote hello world into our file. If we want to read a file to check that, you can use cat. So if I do cat test.txt, it will say hello world because that's what's in the file right now. If you don't believe me, well, I'm on Windows, so I can do notepad test.txt, and it will open a notepad window showing me that that's in the file. If you're on Mac or Linux, it's not notepad, but there's probably another text editor you can open. Or you could just use cat because cat does the same thing. There's also a little shortcut here. If you want to echo directly into a new file, you put a single arrow. May as well show you. Test text into a file called test2.txt. And now if we do ls, we'll see that we now have a new test2 file. And if we do cat on it, we can see that it says test text. So that's just a quick shortcut. You know what else we could do? Delete files. We can do that with rm, and then the name of the file. Let's delete test2. And it's gone. So that's how you do simple creating text files, writing to them from the command line, reading them into the command line, and deleting them. Just more simple bash stuff that we're going to use today. There's a couple of quick tips and tricks that will speed you up. You can press tab to autocomplete what you're writing. So we have test.txt in this folder, and if I want to open it with cat, I just do cat test.txt. But if I want to be lazy, I can start writing it and press tab, and tab will autocomplete. And because there's only one file in this directory that starts with te, when I press tab, it'll autocomplete it to say test.txt. So that's a quick shortcut that can help you out. You can use tab to autocomplete pretty much any command, as far as I know. You can also press up and down to repeat commands you just entered. So I'm pressing up and down, and it's scrolling me through all the stuff I already did. So I can go back up to redo echo to create the test2.txt file, and then I can go back up to find the remove. Or first, let's grab an ls, see it's there. Let's go find the remove command and repeat that. Let's find our ls again. So yeah, it's really easy to repeat commands you just put in by pressing the up and down arrow keys, mostly up. So that's a little shortcut if you're using a lot of similar commands. Good point, Ariel. You can also do cat and then press tab. And because I only have one file, it knows that that's the right file to look at. And if you have multiple files in a directory, pressing tab multiple times will cycle through them. So you guys don't have to do this, but I'm quickly going to step out of my desktop with cd double dot. That's how you step out of a folder. So I'm stepping out of my Git tutorial folder back into my desktop. And now I'm just going to cat and press tab. And it will just show me all my options that I can scroll through. And if I do cat and then n and then press tab, it knows that the answer is notes. So yeah, if there's like 3 options, it will let you cycle through them. For now though, let's go back to hide in our Git tutorial folder where there are few files and it's easy to handle everything. And that's it for a basic overview of Unix commands, bash commands, whatever you want to call them. Okay, let's mock a real Git usage scenario. So as a quick preview, what we're going to do here is we're going to eventually open 2 windows and simulate 2 people working on 2 different computers. And we're going to go through a common use case of these 2 people working together on a project. So for now, we're going to check out our Git tutorial folder. And I guess we can start by opening 2 terminals. So I'm going to open another Git bash window. If you guys are on Linux or Mac, open a new terminal window. And if you need to write the bash command to activate the bash shell, do that too. And we're going to go to the same place, desktop, Git tutorial. You can minimize one of them for now. We're not actually going to use it for right away. We're going to make one folder for each person. So I'm going to do mkdir to make a new folder, and I'm going to call it Felix. You can pick your own names, or you can use the same names as me. It's probably easier if you use the same names as me, just to follow along. So we're going to pretend that Felix is working on a project, and we're going to move our terminal into the Felix folder. cd, that's just change directory. Make sure you guys have a folder on your desktop called Git tutorial and a folder in it called Felix where your mock Felix person will be working. Later, we'll create a folder for the other person. All right, it's time to import a project. So we're going to start by creating a Git repository on github.com. So you can go to github.com. Now, I have all kinds of random stuff on here, and it feels kind of weird that you all are getting this look into my life. But you're going to go onto the top right and click on the plus sign and click New Repository. Make sure you're logged in when you do this. We're going to have to give a name to our repository. I'm going to call mine Git Tutorial. Actually, that'll be confusing. I'm just going to call it tutorial, actually. Description, we don't need one. We're going to make it public. You guys do have the option to make your repositories private, and then you can choose who can see and commit to it. We're going to make this one public because it's not super important. It's just a tutorial. And we're not going to check any of these boxes right now. We're just going to click Create Repository. You won't see the Travis CI either. So click Create Repository, call it Tutorial, and you should see a page like this afterwards. This is just the main page when you create a new Git repository. There's a couple of instructions here. Actually, it's super helpful. GitHub is telling us what commands we need to do. We're going to do this one here. It's quick setup if you've done this kind of thing before. You're going to clone with HTTPS and copy this URL. I usually clone with SSH, but you need to set that up ahead of time, and none of you guys have that set up. So we're going to clone with HTTPS. You just copy this. I'll click here. And then we'll go into our Felix terminal. And we're going to do git clone and then paste that URL. So you might not actually be able to directly paste. I know on Windows Git Bash, you can't actually do Control-V. You can right-click and do paste, or you can do Shift Insert. And I'll right-click and I'll do paste. So it's git clone and then the URL of our Git repository. Now this is very important. Don't clone my Git repository. Don't clone felixlapierre/tutorial.git. Clone the one you just created. So the URL should have your Git username in it. So it should be https://github.com/your username/tutorial.git or whatever else you named it. Once you write that, you can press enter and you should see cloning into tutorial and then warning, you appear to have cloned an empty repository. So why is it giving us that warning? Well, because it's empty. Don't worry too much about that. Afterwards, you could do ls and you'll see that there's a new folder called tutorial. And that's where it got cloned in. So I'm just going to take a moment to explain to you guys what exactly just happened. It's the first time I tried doing this for a Git tutorial. I'm actually going to draw stuff as if we had a whiteboard to try and explain to you guys a bit of what happened. Never done this before, so tell me how well it works. So when we created our Git repository on GitHub, when we were on GitHub, we created a new repository called tutorial. What happened when we did git clone is that in the Felix folder, it was empty. And then when we did git clone, what happened is it created a kind of another repository, also called tutorial. I can't write apparently. Tutorial. On my computer. So there are actually two repositories now. There's one repository on GitHub's end and one in Felix's folder. Keep that in mind. Two repositories. So make sure you go into the new repository with cd tutorial. Let's do that. So when we cloned it, created a new folder, we do cd tutorial. And now we're in the folder. If you're on Git Bash, you should see this master appear. It doesn't appear on all terminals, but if you're lucky, it should show up. That just means you did it right. Another way you can check is with our first git command, which is Git Status. So if you did it right, you should see when you move into your tutorial folder and do Git Status, you should see on branch master, no commits yet, nothing to commit. Hopefully you got here okay. If you ran into any errors or you're confused about something, just write your question in the chat and we'll make sure to help you out. We can also configure our name real quick. So we're just going to do that. We're going to actually do a local configuration so that each of our terminals are using a different user. So we're just going to do quickly git config user.name Felix, git config user.email, and then you could put your email, don't put mine, that'd be weird. And that's it. Just like in this slide, git config, except don't put the global. Git config user.name, put your name, git config user.email, put your email. That's just some little configuration stuff. Make sure to check the status with git status. So that will, it's a command you can use pretty often. It won't work unless you're in a Git repository, so you know you're doing it right if the command does work. I'll just do it again. You should see something like I do on branch master, no commits yet, nothing to commit. That's because everything's still empty. Okay, let's make some changes. So usually you'd be a programmer and you would start writing some code in here. But for our simple example, we're not going to write any code. We're just going to put text files. But in real life, you'd be writing code files in here. And I'll show you an example of that later. So let's add a new file called hello.txt, and let's put our name and favorite color. So just as a quick reminder, if you want to create new files in Bash, you can use touch, hello.txt, and that creates the new file called hello.txt. You can use ls to check what it looks like, and we can use echo to write into it. But I'm going to save some time and just do notepad hello.txt. You can use whatever text editor you want. Notepad will always work on Windows. I think on Mac or Linux, you'll need to use a different one. If anyone knows what the command is to open a text editor on Mac or Linux, just put that in the chat. I'm going to write my name is Felix. My favorite color is blue. And that's true. My favorite color is blue. It's a great color. Write your favorite colors in the chat, please. I'm going to use that later, I promise. Once you've created your file and write the same thing as me, even if your name's not Felix. Just write my name is Felix, my favorite color is blue. And let's close the file. So if you've done that step right, ls, you should see hello.txt. And if you do cat hello.txt, remember cat shows you what's in a file. It will print my name is Felix, my favorite color is blue. Make sure you do that so that you can catch up to that. Okay. You've got a good points. On Linux, you can use Vim. If you know how to use Vim, feel free to use it. I know a lot of people, there's a lot of memes about how hard Vim is to use. Also seeing some colors, awesome. That's a surprise tool that we're going to use later. For now, create your file, write your contents, and do another Git Status. Now we're going to see something different. On branch master, no commits yet. Untracked files, there's one, hello.txt. And it's saying something interesting. Nothing added to commit, but untracked files present, use Git Add to track. That's because Git lets you control which files you want to commit. Right now, our changes are what you would call unstaged, which means we've made changes, but we're not staging them, which means we're not preparing to commit them. Right now, nothing is saved in our repository yet. Whenever you want to save in Git, you have to do a couple of different commands. The first command is Git Add. And Git Add tells Git exactly which files you want to save. So we're going to say Git Add hello.txt. You can just enter that in. And what this does is it moves the changes from being unstaged to being staged, which just means not in the batch of stuff we're going to save to yes, it's in the batch of stuff we're going to save. Once you've done that, do another Git Status. Let's see what changed. Now it says on branch master, no commits yet, changes to be committed hello.txt. That's Git telling us, all right, if you commit now, then these changes are going to be in your commit. And remember, committing is a bit like saving. So if this is all the changes we want, we can commit now. You can use Git Add to control what you want to commit and what you don't want to commit, because sometimes you only want to commit some files. For now, we're just going to go ahead and commit, and you do that with the following command. Git commit, but don't press enter yet. There's one more piece of this. I'm going to do -m, and then in quotation marks, you're going to put a commit message. Now, every time you commit in GitHub, every time you save, you need to put a commit message. And ours is going to be added hello.txt. And make sure you put the message in quotes. Can you commit without adding? I'll show you what happens if you try to commit without adding. But first, we're going to commit after adding. Make sure you put your message, though. And if you do, you should see something like this. 1 file change, 2 insertions, create mode, hello.txt. I've just committed. What does that look like? That means that in our tutorial here, we have a new commit that was created here with our hello file on Felix's local computer. Now keep in mind, there's still nothing on GitHub yet. Everything has happened locally in Felix's folder. I've been skipping ahead on the slides. We just did this one. All right, so make sure you guys have all committed your changes to hello.txt. We're just going to finish this off before I tell you about the other special cases. Now that we've committed, our change is basically saved, but only saved locally, as you can see in the diagram. Let's do another Git Status and see what's changed. Now, it gives us this annoying message saying our branch is based on origin master, but the upstream is gone. This is just because we created an empty repository. All we have to do is it's telling us to do git branch unset upstream to fix it, so we're just going to do that. This is really just fixing a small problem. Don't worry too much about it. Once you've done that, you could do another Git Status. See that everything is normal. Now, our next step here is pushing to the remote repository. So you'll notice that there's no changes on GitHub yet, and if you actually go onto your GitHub and refresh, you'll still see the same page as before with nothing on it, or this example instructions. If we want to push our changes to the remote repository, we do git push. Now I'm telling you ahead of time this command isn't going to work, I know, because it's saying that there's no upstream. That's because Git doesn't know where to put it. Simply put, the tutorial has a master branch. Our local tutorial also has a master branch. And even though we cloned from the master branch, for some reason Git doesn't know where to push it. So we need to tell it to push it to the master branch. And fortunately, Git's error message is telling us exactly how to do that. Git push set upstream origin master. And now Git knows to push to the remote's master branch. Ariel, why doesn't it push it there? I'll be honest, I'm not entirely sure why it tells me to unset the upstream, then reset the upstream. It happens every Git tutorial. I think it's a consequence of cloning an empty repository. It kind of glitches out. It's not like able to see it for some reason. But now that I've done git push set upstream origin master, I'm saying, okay, push to the remote repository's master branch. And then it goes bloop, 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 new branch master tracking master, branch master, set up to track remote branch master. All that to mean now it pushed, and GitHub also has hello.txt. So I've taken my changes that I made locally on my computer, and I've pushed them up to the remote repository. Now if you go to your remote repository and refresh, you should see hello.txt. So maybe that was a bit fast. I'll just go back, scroll up a bit. When it tells you your branch is based on origin master, but the upstream is gone, You can fix that by doing the exact command it tells you to do, which is git branch unset upstream. And if it tells you the current branch has no upstream, do exactly what it tells you to do and do git push set upstream origin master. Make sure you put those changes through. And once you do, you should see, these are basically the messages of Git enumerating objects, counting objects, writing objects. That's just logs of it saving the data and pushing it. And then this saying it successfully decided our local master maps to the remote master. And now we have hello.txt up here. And in GitHub, we can look at the file and see that it says, my name is Felix, my favorite color is blue. And now anyone else who looks at your repository will see that. If you got any errors, just write it in the chat. Often we get people who run into problems and get weird error messages, so write it in the chat and I'll try and help you out. Answering the question, can we commit without adding? Well, if you do git commit, it'll say there's nothing to commit because I didn't add anything. It's like saving when there's nothing to be saved. It's not going to do it because commits can't be empty. And if you've added some things but not others and then commit, it'll only actually put the things that you added into your commit. All right, hopefully none of you are running into any errors. I'm not seeing anything in the chat, but please post them there. Done the workshop for years. I've seen all kinds of errors, and there's always something new to be learned from the weird errors people get. All right, let's keep going. Let's actually collaborate, because one of the main perks of Git is that you can work on it with other people. So let's switch to Terminal 2. So remember a long time ago I opened a different window. This one's not in any folder, it's just in the Git tutorial folder. If we do ls, we see our original test.txt file and the Felix folder. So we're going to pretend that Felix is working collaboratively with his friend. We're going to call his friend Andy. We're going to name him after my good friend Andy. And we're going to use mkdir Andy, and that will create a new folder named Andy. How do we write to a file on Mac? You can use echo, as we did earlier, to write into a file. I don't know what the command is to open a text editor on Mac. If someone can write that in the chat. I'm doing a quick Google search. I think you should be able to do open a text edit and then the name of your file. According to Stack Overflow, which is of course the savior of programmers everywhere, I'm pretty sure text edit is installed on all Macs. This command isn't going to work for me because I'm on Windows. When in doubt, you can always use VI, which should pretty much always be installed. Vim, VI. Maybe Nano. Do I have that? Yeah, but these are like command line text editors. I find them really hard to use. I'm just going to get the hell out of here. I can use Vim though. So hopefully one of those works for you. Otherwise, you can just go into the folder using your Finder and open it with your mouse and edit it there. Up to you. Yeah, you can use any text editor. Let's head back to what we were talking about. We were bringing in our second person, Andy. Try the text edit command if you want to. So I've created a new folder next to my Felix folder in my Git tutorial folder on my desktop. And this folder, Andy's going to work in instead of Felix. So we're going to call this window Andy, and I'm going to move into my Andy folder with CD. Now Andy wants to work on this project with Felix, so he's going to go back here and clone the repository. I've realized also when you push, you might be prompted to log in. It might ask you to enter your username and password. I'm seeing, is there any way to access the Google slideshow? The link is, I will write that in the chat. Hold on, let's just go back and check. Okay, I've put the link in the chat for you. Okay, I promise we'll get through more of the tutorial before I answer questions so I don't get distracted. Right. Open your terminal with Andy, separate terminal, and I'm going to write this in my little document. We have GitHub right now with stuff on it, and now we're also going to have Andy. Oh God, my handwriting. Andy doesn't have anything here yet. So we want to clone into Andy's folder, and we're going to go back onto GitHub and grab the link. I'll clone it with HTTPS again. Click copy. Go into Andy's terminal, not Felix's terminal, and do git clone again. And again, you might not be able to control V, so you can always right click and do paste, or do shift insert to paste into your terminal. So now I've cloned a second time. Git clone and then the URL. Remember to clone your repository, not mine. Don't write github.com/felix.pierre. Write github.com/yourname and then your repository name. And you should see something like this, cloning into tutorial. Now if we do ls to get the list of files in our directory, we now see the tutorial folder, which we can move into. If everything happened correctly, then when we do git status, we should see that we're on branch master. If you do git status and you're not in a Git repository, you're going to get some sort of error. So keep an eye out for that. Going back to our diagram, Andy now cloned the repository, so he also has tutorial now. But because he cloned it now you see that the hello is on the remote repository. He also has the master branch with hello. I should zoom in more to write more easily, but hopefully you guys understand what's going on here because it's hard to write with this. So Andy cloned the version that already had the hello.txt. So if we look at it and do ls, we already see hello.txt. And if we use cat to read the contents of the file, we will see my name is Felix and my favorite color is blue. So now there are actually 3 repositories total. There's the GitHub repository online in the cloud. There's Felix's repository in his folder, and there's Andy's repository in his folder. But Felix and Andy could be on different computers if they wanted to be. Just for the sake of tracking that this is a different person, we're going to set a different name for Andy with git config user.name Andy. I'll show you guys what that does later. It attaches a different name to your commits, and we'll be able to visualize that later. So another surprise tool that we're going to use later. All right, let's talk about branching. So branching is super useful when two people are working together, which is what we're doing. So suppose Andy comes into the project, which is just a text file, and he says, you know what, I'm going to change what color it says. Let's go check out a new branch. This is another Git command we have here. Back into Andy's terminal, Git Checkout -B color. And I'm putting the British/Canadian spelling. When you wrote ls, you got tutorial. Then use cd tutorial, and you'll be able to move into the folder that you created when you cloned. So git checkout -B color creates a new branch called color. Let's do that. Switch to a new branch called color. And then we'll see here it will say color instead because I'm on a new branch, because that just says what branch I'm on. I'm going to answer some questions and let you guys catch up. So yeah, Umar, you're saying when you wrote ls you got tutorial. That's because after you clone, it creates the tutorial folder, so you need to move into it using cd. For the rest of you, you don't have to do this, but I'm just going to move out of this folder using cd ... which just leaves the folder I'm in. So when you say ls, you should see this tutorial. If you do cd tutorial, now you're in the Git repository and you can do Git status. Another person saying the Git bash no longer allows you to put any new input, like the $ in the header disappeared. If you're in Windows and your Git bash isn't letting you do that, then you should probably just have to close and reopen it. If you're on Mac or Linux, it's probably because you opened a second terminal. Maybe. You can try just writing the bash command, and that might fix it and give you the $ back. So try that out and let me know if it works. Okay. So now Andy has checked out a new branch called color. That command was git checkout -B color. So use -B to indicate that you're doing a new branch. When you're checking out a branch that already exists, you don't put the -B, you just put the branch name. I think our fellow watchers figured it out instead of me. Control C, yeah, that was probably the right move. All right, let me just show you guys what this looks like in this terrible, terrible drawing. So far we've only been working on the master branch. Now Andy's repository has a new branch here called color. It still has the hello.txt. Try the Control C, that will probably work. So keep in mind, this branch only exists in Andy's version of the repository. It doesn't exist on the other ones. But it was created from the other ones and has the same things on it. Now what's Andy going to do here? Andy is going to change the color that Felix put in the file. So on Windows, I can just do Notepad hello.txt to open it. On Linux, gedit might work, Vim would work. On Mac, try open -A text edit like I showed before. I'm on Windows, so I will do Notepad hello.txt. And we're going to change the color in this file. So when I asked you guys to say your favorite color, the first result that I saw was red. So we're going to change from blue to red. We're going to hit Control S to save, and then we're going to close the file. Once you do this, do cat hello.txt, and you should see my name is Felix. My favorite color is red. I'm also going to add the extra I'll add that there for the future. Okay, question. The branches are related. Color builds on a hello branch. What happens if you remove the hello branch? Just to specify, there's no hello branch right now. There's a master branch and a color branch. I just wrote hello because that's the commit where we added hello. The color branch comes from the master branch and has all the commits of the master branch. If you delete the master branch, though, the color branch will still exist and be alive. It will still look like the master branch. Branches don't really build on one another. It's more that when you create a new branch, it gets all the commits from the previous branch. Okay, Andy made the color branch, and Andy changed the color to red. But remember, we haven't actually committed anything yet. So we haven't saved these changes. If we do Git Status, we'll even see changes not staged for commit, modified hello.txt. No changes added to commit. We asked before what happens if you don't Git Add. Well, if I try to Git Commit now, it's going to say no changes added to commit. You can't commit if there's nothing in it. So first, let's add our changes. If I do Git Add hello.txt, that will add hello.txt to my currently staged changes. Let's do a Git Status, and it says, oh, here's changes that can be committed. The next step to finalize our save is Git Commit. And remember, when you commit, you always need to put a commit message with -m. And it's good practice among programmers to put a descriptive commit message. So a commit message that really tells other people what you did in that commit. So here we're going to say changed favorite color from blue to red. Make sure you put quotation marks around it, and then press enter. If you don't put a commit message, it's going to open a text editor and tell you, hey, put in a commit message, please. So look out for that. And I'll show you guys what that looks like next time we commit. So now I've committed changed color from blue to red. Let's go back to our diagram and see what that looks like. Now Andy has made a commit on the color branch. And in his commit, he's changed the color to red. So I'm just going to put that to indicate that the color is now red. This commit is only on the color branch, and it's only in Andy's repository. So nowhere else will the color be red. Also, these changes aren't on GitHub yet. They're only on Andy's local repository. I skipped over git diff, so we'll do that next time. Let's push actually first. So if Andy wants Felix to have access to his changes where he changed the color to red, he needs to push them to GitHub so that Felix can then grab them. So on branch color, let's do git push. And now it's going to say color has no upstream branch. Why? Well, if you look at our diagram again, on GitHub, there's no color branch. There's only a master branch. Did I do a get status on Felix? So let's push our changes to the remote. Let's do git push. And by doing set upstream origin color, we're telling Git to create a new color branch on the GitHub repository, the remote repository, to put our changes on. Now that we've done this, what happens in our diagram is now there's a color branch on the remote repository that has our change with red. Matching the change we made on Andy's repository. And as Ariel noticed, for your convenience, it gives you an automatic link for creating a new pull request, but we'll talk about pull requests later. So now, if Felix wants to see those changes, remember from our diagram, Felix doesn't have the color branch, he doesn't have the red anywhere. And if he wants it, he's going to have to do git pull. So let's head back into the Felix terminal window. I minimized everything again because I'm very clever. And let's do git pull. Now git pull will pull all the changes from your remote repository onto your local repository. Let's press enter. And it will say a couple of things. So new branch color from origin color, already up to date. If you do git branch to list all the branches we have, it didn't actually create the color branch on our local, but now Felix knows that the color branch exists on the remote. It didn't create a color branch for him though. However, Git is smart enough that when he checks out the color branch, it's going to grab it. So I know I'm hopping between a lot of windows. I'll slow down a bit. Back on Felix, we just did git pull. We now know that there's a color branch on the origin. So we're going to do git checkout color. Now notice I'm not doing a -b because if I do it, Git is smart enough to see that there already is a color branch. I am creating a new branch, but I'm also not technically creating a new branch. But because there's already a color branch on the remote repository, it's just going to say branch color set up to track remote branch color from origin. As soon as I did this, what happened is now Felix also has, the color branch with the red. And we can prove that by doing cat hello.txt and seeing my name is Felix, my favorite color is red. Now remember, we still have the master branch in all of these repositories. So if I do git checkout master, git checkout master on Felix, and then do cat hello.txt, the color is still blue. And that's the magic of Git, right? The color branch was just a small, short-lived branch to change the color. If we go back to the master branch, things are still as they were before. It still says my favorite color is blue. But if we git check out the color branch and then do cat hello.txt to look at the contents of the file again, it's red again. But on master, it's blue. But on color, it's red. So you can see how awesome that is, because if you and your friend are coding the same file at the same time, if you're on different branches, your changes aren't going to get in each other's way. It's one of the big perks of Git. But sometimes things aren't always happy and easy like they are here. Sometimes you have to merge, and let's talk about how that works. Let's start by Felix. All right, what's our status right now? Color branch, it's all over the place, and on every single color branch, the color is red. Maybe Felix disagrees. Color red is not the right color, but maybe neither is blue. Maybe, like I asked before, I have some more colors there. Maybe Felix thinks the favorite color is actually pink now. So let's open hello.txt. My favorite color, let's change that to pink. I will close this and do another git status. So see, we have more changes on hello.txt. So if we want to save these changes, then we have to do the same commands as always. We always have to start with a git add to get those changes ready to be saved. And I'll let you in on a little secret. If you're too lazy to write your file names, you can just put dot, which is the wildcard character. And if you put dot, then it will just add every single file. Let's do another git status. Hello.txt has been modified. Finally, we do git commit. So again, I recommend you put your commit message in -m, but just to show you guys what happens if you don't put a message, I'm not going to put one. For me, it's going to open Vim, because Vim is my text editor on for Git. And it's going to say, please enter the commit message. Now, if I want to quit this, I can do :q just to quit. But instead, I'm actually going to write changed color from red to pink. I'm going to press escape to stop inserting, press : to enter a command, WQ to write and quit, and then enter to confirm. And that's just how Vim works, but just always put a commit message and you'll be fine. And if you get stuck in Vim, just Google how to exit Vim. Let's do quick git status. Your branch is ahead of origin color by 1 commit. Use git push to publish your local commits. We're not going to do that right away. Quickly, let's show what we did here. So now what Felix did is he added a new commit to our color branch, one that says change red to pink. But this commit is only on Felix's repository. God, that's an ugly circle. Okay. I did the Git Checkout Color and it said blue. If you did Git Checkout Color and it still said blue, you probably didn't push from Andy's end. Probably. So try going back to Andy and doing where you changed the color to red and do git push. And if you need to git push set upstream origin color, then do that. And once you've pushed it to the GitHub repository, you can head to Felix and do a git pull, and then you should see red instead of blue. That's probably the step you missed, but not 100% sure. If you need to, you can go back through the video later to double check all the steps I did. So to recap where we're at right now, we just went on Felix's repository and changed red to pink. On Andy, it says, tell me who you are. Hold on. Okay. I've also realized that I have my Git set up locally to not ask me for my username and password. Have you guys, when you've been pushing, has it been asking you to enter your username and password or not? Just let me know in the chat. In the meantime, though, let's keep going with the instructions on merging. At the same time, let's change the color again. What was the other color that I got in the chat earlier? Green. Okay, it's been asking you guys. All right, for the next workshop, then I'll make sure that I disable that because you've clearly been getting a lot of stuff that I haven't. Sorry about that. Hopefully that hasn't caused you too many issues. Okay. So Felix has changed the color from red to pink. Now let's say Andy comes in and says, screw all that. The best color here is clearly green. So he's going to new notepad, hello.txt, and you can use your text editor of choice and change the color to green. Save, and then exit. Same commands as usual, although you don't need to do Git Status if you don't want to. We're going to do Git Add, hello.txt to say I'm ready to save that. Git Commit to perform the save, and we're going to say changed color from red to green. So make sure you do the same changes that I did. Now what's happened is Andy over here has made his own change. He said changed red to, and let's get ourselves a nice green. Green. All right, so make sure you've changed the color to green on Andy's branch and to pink on Felix's branch. And apologies to people who got stuck or got errors and aren't able to keep up. I wish the workshop was in person so I could check out your computer and help you. Hopefully the advice I've been giving you is able to catch you up. All right, when both people make changes on their own branches, obviously they won't be able to see the color the other one put. Felix can't see the green, Andy can't see the pink. If you, they've both committed without pushing yet. I haven't pushed any of them yet. They've both done work locally that the other person can't see yet. But now we're gonna finish that off. So let's start with Felix. Say Felix decides he's gonna push first. Do a little git push. Now fortunately it knows which branch it needs to push to, and it successfully pushes to the color branch. So now let's represent that up here. Here we see pink. All right, fairly straightforward. Now it's Andy's turn. So I'll tell you guys, one golden rule of Git is that you always pull before you push. I've been breaking that rule, I've just been pushing, and I'm gonna break it again. I'm gonna push before I pull, which is a big no-no. Fortunately, Git is smart, and Git is gonna tell me, error, failed to push. Updates were rejected because the remote contains work that you do not have locally. So that's Git saying, hey, you have the red, but you don't have the commit with the pink. and you're trying to push new stuff, and Git won't let you push new stuff until you have all the stuff on the repository, until you're fully up to date. That's kind of like a safety, a safeguard, because you always have to pull before you push. Otherwise, this happens. All right. Andy's going to pull then. Git pull. And now we see conflict. Merge conflict in hello.txt. Automatic merge failed. Also, I see this big merging thing. What on earth just happened? Hopefully you see the same error as me. Otherwise, you'll have to follow along. What happened here is Andy pulled, and Git was trying to take this pink up here and bring it down there. But there's a problem, see, because what Felix did is he changed red to pink. And when Andy pulled, Git said, oh, I should change red to pink so that I'm up to date with the changes. Except the color on Andy's branch is green, and you can't change green to pink. That's not possible. If one person changed red to pink and the other person changed red to green, those changes are fundamentally incompatible. So this triggers what we call a conflict, a merge conflict, actually. Merge conflicts are annoying. When I was in my first year, I went to a competition called CS Games, and I was doing a very important competition called Team Soen with my friends Mike and Maury, and we lost probably an hour at the competition dealing with merge conflicts because one person wrote code, the other person wrote code, and we tried to merge it, and it was just a huge mess of Git saying merge conflict, merge conflict, merge conflict. Let me tell you exactly how you fix merge conflicts, and hopefully you won't deal with the same problem I did. Let's hop into Andy's terminal, because Andy has the merging problem. Merging. If you do a Git status now, it should tell you your branch and origin color have diverged and have 1 and 1 different commits each, respectively. You have unmerged paths. No changes added to commit. This is Git saying you're currently in the middle of merging. Okay, what does that mean? Well, let's open hello.txt. And this is what we see. It looks a little bit weird, but I'll break it down for you. What Git is showing us is it's showing us what we have on our branch and what's going on in the remote master branch. Andy changed the color to green. And the head of Andy's branch is called head. So this is what we had on our branch, on Andy's branch. This is what was on the GitHub repository. And the reason there's a big weird thing here is this is actually the commit hash of the commit that changed the color to pink, which is a fancy word for saying this is the ID of the commit that changed the color to pink. What Git is saying is your branch says green, master branch says pink. I don't know which one's correct. You tell me. And if you use Git in a user interface, there'll be extra buttons and fun stuff to help you figure that out. Okay. How do you fix this? Well, first we got to decide what color we're going to settle on. And we're going to settle on, well, Andy would probably think it's green. But maybe he says, you know what, Felix is right. The best color is pink. So we're going to stick with pink. What you want to do when there's a merge conflict is change the file so it looks exactly the way you want it to. And we want it to say pink, so we're going to straight up get rid of the green. Finally, we need to get rid of all these extra lines that Git added with these arrow symbols and equal signs. So you can just trash that and trash that. And notice now the file looks exactly the way we want it to, which happens to be pink. Once you're done, save your file and close it. Pretty straightforward. Careful though, we're still merging. If you want to finalize the merge, you have to add your file and commit your file as usual. So git add hello.txt, then git commit fixed merge conflict, color is now pink. And once we've committed, you see as soon as I committed, we're no longer in the merging state. If I do a git status, it says we're ahead by 2 commits. Okay, so we can just push, and now all is well in the world again. What just happened? Well, Andy pulled the pink commit down, merged it with this one. So now there's a new commit, which is the pink commit. And there's another commit, which is there another commit? No, there's just that one, I believe. Let me just double check that that's the only commit so I don't tell you guys the wrong thing. I'm getting ahead of myself with git log. Yeah. So instead of directly taking the pink commit, what Andy did is he took the pink commit and changed it a bit so that instead of changing red to pink, it changes green to pink. Like that, everything fits nicely together. And then we pushed. And when we pushed, now it's actually funky. It looks like, well, let's actually go see what it looks like. You can use the git log command to see a history of commits. I used git log one line so that it's more concise. Andy's branch, the latest commit is fixed merge conflict, color is now pink, and then it's changed color from red to green. You'll see that red to pink is there actually, so I guess it ends up behind. At the end of the day, the point is that Andy pushes back to here, and ultimately it's still pink. And the merge conflict is fixed, and everything is happy in the world. Ariel, you think you did something weird and have 2 heads. You should see a doctor about that. That's terrible. 2 heads. I guess you can see twice as well. I don't know how you would get 2 heads. Usually you should only have 1 head always points to the front. If you're in a merge conflict, then open the file and fix the merge. And then just commit, and it should fix itself, but I've never actually encountered that. Maybe send me a screenshot. And that's the merge. So we fixed all the extra stuff and put it together. All right, making a pull request. So once you're done working on a feature, once you're done with a branch and you want to put that code back into master, you can make a pull request. Typically, the reason you make pull requests instead of just merging things directly back up into the master branch is that you want other people to look at your code. Now keep in mind, everything we've been doing with this has been on the color branch. Our master branch still says blue. How do we create a pull request? Well, you actually do that in GitHub. I know it's possible to do it in Git, I think, but we're going to do it in GitHub. And the way we're going to do it is go into the GitHub page for our repository. Now there is a shortcut here, but I'm not going to use it in case you don't see it. You're going to click on pull requests, and you're going to see welcome to pull requests. There's nothing here. You're going to click new pull request, and it says base branch and compare branch. Base branch, you want to leave that as master, and we're going to compare with the color branch. Now you're going to see all of the commits that are on the color branch, which means all of these. My color is still pink. My diagram's a little bit off, as you can see. because there actually is 4 commits. There's change color from blue to red, change color from red to pink, red to green, and fix merge conflict, color is now pink. So those are the 4 commits, 4 saves that we made, really. And if you click on any of these, you can see exactly what happened there. And you can see that they kind of follow each other, because it's change color from red to pink, and then change color from red to green, but then the merge conflict comes in and changes the color to pink, and now we're left with pink. You just click create pull request once you're ready to make it. You can give a title, so changed favorite color. You can leave a comment with that. So you can put, you don't have to write this down. I'm just going to put, decided that the favorite color is pink, not red or green. But you don't have to write this if you don't want to. There's also a couple of extra things on the right that you can figure out on your own, explore on your own someday. Create a pull request. And now pull request, there's one, change favorite color. Once you create your pull request, usually you'll message your friends that you're working with or coworkers and say, hey, can you review my pull request? And then they can go look at the file changes and think, yeah, okay, that seems pretty legit. They can also review it. I'm not going to go over too in depth with that. But for now, we're just going to merge it. So it's saying there's no conflicts with the base branch. We can just automatically merge. So when you're ready, you can click merge pull request, confirm merge. And now it says pull request successfully merged and closed. What just happened? Well, now when we merged, it took all these commits and stuck them on the master branch, which is red, green, pink, and then the merge commit. Doesn't matter. The point is now everything's on master, on GitHub. Be careful though, because Felix and Andy's master branches are still old, and they're going to need to do a git pull if they want to get the up-to-date master branch. Hopefully you get the idea by now of what the difference is between the 3 repositories and how you have to pull to get the changes. And once you've made your pull request, you can delete your branch. Usually you only use a branch once, and once you merge it, you delete it, typically. You can leave it open if you want to, but you don't have to, because rest assured, all your commits are safely on the master branch now. And now if we go to the master branch, hello.txt, we see my name is Felix, my favorite color, it's pink. Question, does it record all the commits from both users? Yes. What's wonderful about Git is it keeps everything. If you look on your GitHub now, and you see this page on the right here, there's a 6 commits on the right. If I click on that 6 commits, and I will see a history of all the commits of the entire history in the repository. So this is our added hello.txt, change color from blue to red, change from red to pink, change from red to green, our commit where we fixed our merge conflict, and one extra commit that Git made when we merged our pull request into master. And you can always go back to look at these and see the changes that were made. It will always keep all the commits from all the users. You don't need to worry about losing any information. That's what's wonderful about it. Even if you delete the color branch now, the commits will always exist. They will always be here forever. And you'll notice all of these are from Felix Lapierre, because that's my GitHub account. But if we go into Insights, into commits, is it commits network, I think, actually. Yeah. If you go into the network here, you can even see a little graph like the one I was trying to draw for you guys of all the commits and on which branches they were. And now you'll see when I hover that it will tell me, oh, I zoomed in, so the hovering is weird. It's going to be really small. No, okay, it's still not hovering. This one says Felix Lapierre. This one says Andy, because we set the user to Andy. Andy fixed the merge conflict. Andy changed the color from red to green. Felix changed the color from red to pink. Andy changed it from blue to red. It tells you exactly who did what based on the user.name. Although the merge was done from the internet, so it says merge pull request by Felix Lapierre. And yeah, be sure to do git pull origin master or git pull when you're on the master branch. Otherwise, you won't have the latest changes. So there's a lot of questions now, so I'll start by addressing those questions, although we've covered the main topics, except logs and going back in time. So I'll answer the questions that are cropping up. Is there a way to prevent other people pushing to your repository? So that all happens in GitHub. So right now I have a public repository, but Ariel, if you clone my repository right now and try and push to origin, as in, because it's public, push to origin means pushing to GitHub. The repository in GitHub is called origin. Or rather, origin refers to the online repository that you're pushing things to. So my origin here is public. So Ariel, if you wanted to, you could clone my repository onto your end and get all of my commits because it's a public repository. But you won't be able to push. It won't let you push. Why? Because you're not a contributor. Whoops, I opened a folder. So even if a repository is public, you have to be on the list of contributors to push things to the remote. Remote means the same thing as origin when I'm talking. To push to GitHub, you need to be in the list of contributors, and you can see those in settings, manage access. Don't look at my password. I don't have any collaborators on this repository. Only I can push things to the master branch. If I look at a different repository, like my minicap project, which was called Campus Guide, and it's a mobile app that shows you the Concordia campus. If you go here into manage access, these are all the collaborators that are registered on this repository. Only they can push to master. So you have full control over that, even if your repository is public. So don't worry about that. Also, speaking of the master branch, let me go back actually to my mini capstone project. In the settings for a repository, you can do branch protection. So I have my master branch here set up so that you can't push directly to master. You have to pull request. And you need to even have reviews to merge to it. So you can even set it up so that even though 10 people are allowed contributing code, they can't merge to master unless you approve it, or you can make it so they can't merge to master unless 2 other people approve it. And they can't push directly to master. So you can configure all of that kind of stuff in GitHub. What if you want to edit the commit message? So you guys can stop following along now because I'm just answering questions. I'll show you how to edit a commit message. So if I change the value in here, I add another line. My favorite programming language is C#. Save, close. All right, I have modified Git Add, Git Commit, and I do Git Commit and say I accidentally put a stupid commit message like smashing the keyboard. If you haven't pushed your commits yet, you can use the Git amend. So sorry, Git Commit amend. And when you do, it'll open your text editor and you have the chance to edit the commit message. My text editor of choice is Vim, so I need to use Vim, and I can put added a line about my favorite programming language. And then I can finish that. And now I've changed my commit message. You can view your past commits with git log. I already did that once. Let's do it again. And now it says, added a line about my favorite programming language. I can press Q to quit that. But as soon as you push, oh, I need to pull first. God damn it. Forget about it. I don't want to fix this. Fine. Notepad, hello.txt. Yeah, I get it. There's no extra line on the remote, but I have one. Just quickly fixing this merge conflict. Git add, git commit, git push. Okay. As soon as you've pushed, you can't amend your commit because it's already online and other people might grab it. Once it's online, you do git commit amend. I think you would have to force push to get it to go through. Basically, don't edit your commit messages after they're online. You might be able to do it and force push, but it's ugly. Git is set up so that it makes it intentionally hard to edit your history and delete the past. Is it possible to delete a branch if one was created by mistake? Yes. I'm going to pull so we're up to date. Let's check out a new branch. Let's call it mistake. Switch to new branch mistake. Say I don't like it. You can do git branch -d for delete, and then the branch name. Note, you can't delete a branch if you're on that branch. So I have to check out the master branch, back to master, git branch, delete, mistake, and it says deleted branch mistake. You will get a warning if you delete a branch that has changes that weren't pushed, because it's trying to tell you to be careful about deleting branches that have changes on them. But if you really want to delete your branch, do capital D instead of lowercase d, and then it will delete it no matter what. But be careful with that. I think that's all the questions at the moment. So let's keep going. Thank you so much to everyone who's still here, by the way. You guys have toughed out till 8:15. We've only got a couple of topics left before I'll switch to just questions. So I've already talked about logs. Git log will show you all of the changes. It's like a history. It has a lot of detail, like the commit numbers, author, the date and time, commit message. I keep pressing enter and I see more. You'll also see the commit hash. Each commit has a hash. It's unique. No two commits have the same hash. And you can use that to refer to that commit if you want to say, like, do any kind of commands that operate on commits. These are unique. And you can see all of them in git log. Yeah, you could do git log --1 line if you want to just see the first 7 digits of the hash and the commit message. So I usually use this one because it's cleaner, easier to scroll through. There's a fun one too called git blame, which will show you, it'll be easier if I full screen this. It shows you the contents of your file, and it tells you who last changed it and when they last changed it. So if you see a line of code that's broken, you can use git blame to see who broke it. But really, it just shows you the last person to change it. So Felix is the last person who changed the first line, and he's the last person to change the second line. Let's talk about going back in time. I said one of the big perks of Git is that you never lose information. You can always go to an older version, which is wonderful because, like, maybe your code was working a week ago and then you broke it. You can do this funky thing where you go back in time one commit at a time until you find the exact commit that broke your code. Super helpful. Remember how I said each commit has a unique commit ID? For example, changed color from blue to red. The commit ID is FF7122D. It's actually way longer than that. It's actually this. But you usually, the first 7 digits are enough to uniquely identify a commit. So I'm going to copy ff7.122d. I'm going to do git checkout and paste that. Whoops. Looks like it didn't copy right. Git checkout ff7.122d. A lot of stuff being printed here. You checked out this commit. You're now in detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by performing another checkout. Basically meaning you can look at stuff. Oh, look, favorite color is red because we went back in time to when we changed the color from blue to red. Well, you can look at all the old changes, you can run the code, you can even make changes, but because you're like at an older version, if you want to actually make changes to this, you need to make a new branch because you're like in the middle of a branch right now. Right now, we're over here. Hold on. We're like here right now. I didn't even change the color. So you can't really commit because there's other commits in the way after. If you want to make changes now, you have to like make a new branch to stick them on. But this is useful so you can go back in time and see what's going on, what the older version of your code is. If you want to leave, you just do git checkout like master again, and it'll bring you back to the head of the master branch. So that's how you go back in time. You can go back permanently if you want to. The command is right here on this slide. It's git reset --hard and then your commit ID. But we're not going to touch that. That's very dangerous. That's like, if you do that, you're like Thanos snapping away half the commits when you do that. If you hard check out this commit, then all of these totally get deleted. And it's dangerous to do that, so don't do that. If you're going to do a hard reset to this one maybe, because then you don't destroy anything. But yeah, don't. Be careful when you hard reset. Make sure you know what you're doing, because it is a hard reset. There's no one doing that. There's a couple of bonus topics. I can talk about these if you guys want to, but it is getting a bit late. So just mention it in the chat if you want me to cover one or more of these topics, and I'll cover them if you guys want to. I'm super happy to talk about it. I just want to make sure that you guys are interested in sticking around for it. If you have other questions about other Git-related things too, I can cover those. Ariel, if you wrote bad code and wanted to restart fresh, it's okay to reset hard. The thing is, if you hard reset, you're like deleting all the bad code you just wrote. So like, if in a week you're like, you know all that bad code, and if you want to get your bad code back someday, you can't. It's gone forever. If you want to restart fresh, I would say check out this commit, make a new branch, and start reworking on that branch. And then later you can like delete the other stuff. But delete it by like merging this branch in front, you know? Or manually make a commit that deletes your code. You can actually do that with, there's a command to revert commits. I suggest you look that up actually instead. I promise you, even when I use Git, I'm Googling everything. There's a Git Revert command to revert an old commit. I suggest you use that instead. Like, if you revert a commit, it literally makes a commit that does the opposite of the old one. So yeah, if you really have bad code, just revert this commit, revert this commit, revert this commit, and then start working. Because then you can always revert your revert and go back to your old bad code version. How would you recommend practicing what we learned today? How can we learn more? I agree with Rayan. You do want to try it with your programming assignments, even the easy ones, because that will just get you used to the basic commands, the Git Add, the Git Commit, the Git Push, even if you're working alone. Because it's important to learn just that basic workflow of how you add, how you commit. The way I learned it is I actually did this workshop and then didn't touch it for 3 months. And then I went to a hackathon and then I kind of relearned it during the hackathon, but it was easier because I'd already done the workshop using these slides. So I'd strongly recommend, like, the next time you do an assignment or a programming project, use Git and save it with Git, stick it on your GitHub. And then just by force of using it, you'll learn the commands and you'll get comfortable. And then you'll make mistakes, and then you'll Google how to fix your mistakes, and then eventually you'll know a lot more about how it works. Also, because if you look at my GitHub, a lot of these are personal projects that I did with Git, even though I was working on them alone. And a lot of these are projects I did in school. So like I made Minesweeper using JavaScript as a personal project. And I put it on my GitHub because you can also put it on your CV, put a link to it on your CV, and then anyone who hires you will see it. What are they? What are what? The new commands? I mean, I'll just go over them since you're interested, Ariel. Git Ignore. Why do I have this rotated? Why do I think I'm funny? I'll just show you guys what that looks like, actually. Let's look at one of my coding. Is there my mini cap? Campus guide, cool. So Git Ignore is a file that lets you ignore other files within Git. So this is my mini capstone project. Our Git Ignore looks like this. Every single file you write the name of in the Git Ignore is going to be ignored by Git, which means it's not going to get added to your commits and it's not going to end up in the remote Git repository. For example, all your build folders for your code, those contain like your compiled binary files or your class files. You don't need to store those in Git because anyone who clones your project can just build and get them for themselves. So you ignore them because they take up a lot of space. We also have some API keys. You don't want to put API keys in your repository because those need to be secret. Code coverage reports are a good thing to ignore. DLLs that you just want to download separately. Built application files. You can put wildcards to ignore any like file. Like this ignores all files that end with APK because those are Android built application files. And it really just avoids saving these in the version control. And yeah, you want that because it makes your repository take up less space and also just avoids like unnecessary conflicts and stuff. Very useful. You'll figure out when you use it, like you can look up typical Git ignores for different programming languages. So this one was auto-generated for Android because this was an Android project. And then we added some stuff like this. IntelliJ files, Grado files. Useful stuff to ignore. Also stuff like configurations that everyone has their own configuration. You want to ignore that so that people can have different stuff without it conflicting. Yeah, that's Git Ignore. You can look up how it works, but it's fairly straightforward. Just useful to avoid putting unnecessary stuff up there. If you have any questions, ask. Squash and Rebase, they fall in the interactive rebase command. So squash is useful because it transforms multiple commits into just one commit. I'll do a quick example here. Yeah, if your file is in the Git Ignore, you can't even Git Add it. When you do Git Add, it's not going to show up in the list. Like, it's not possible anymore. Useful because you don't want to add those anyways. Git Rebase. Let's try this. Okay. So what I just did is an interactive rebase. Rebase is a command that lets you modify other commits. I did git rebase -i to do what's called an interactive rebase, which lets me do stuff. For example, reword lets you edit the commit message. Someone asked earlier about commit messages. This is another way to change the commit message. Edit means it will keep the commit, but like it'll take the you know, maybe I should just do some of these. The way I do this, by the way, these are the commits I'm rebasing. It says pick because I'm not going to do anything. I'm just going to keep them. You can do drop if you want to like get rid of this commit entirely. You can do edit if you want it to stop and let you change the commit, change the changes that are in it before continuing. You can do a lot of stuff. Reset means that it's like doing a git reset to that commit. Here we're going to do squash. So squash says use commit but meld into previous commit. So if you're the kind of person who commits constantly, you are going to want to squash your commits so that they become less, because it's really confusing when there's 30 commits that each change one line. Maybe you'd rather have a couple of smaller ones. I'm not sure if this will work. I think I did it. Oh, there's a conflict because I squashed them. Let's just abort the rebase. I'm not going to bother going through it. But yeah, the point is that squash will take all your commits and squash them into one. So if you have a ton of commits and you don't want there to be too many, you can do that. An example of why it's useful, if you look at, again, my campus guide project, if you don't want to have like 1,000 commits on your master branch, you can configure your GitHub repository in, is it in here? For merging, you can say don't let people do merge commits or rebase merging. Force everyone to squash merge. And the reason this is useful, squash merging, that is if you look at this repository, this project took us 4 months. There's only 95 commits because whenever someone merged, it took all the commits of their merge and turned them into one. For example, look at this commit. It contains all these commits in one, which is useful because instead of being like 30 different commits, it's only one. We can see all the changes in this feature in one shot. And if you do want to see them as separate commits, you could just go back to the pull request and look at the commits in here from the pull request. Now, like on my last 2 internships, they forced me to squash merge every time in the whole team. So I would say that that's something a lot of companies do, and it's something that I always do in my projects because it makes it really easy to revert a feature and all of its commits. So squashing is really useful, especially for squash merge. Yeah, so is there a way to delete an entire directory that's not empty? Ariel gave you the correct answer. It is rmrf. I will give a quick demo. Tutorial's over, so I'm going to delete all of Andy's, say cannot remove Andy, it's a directory, okay. rmf Andy. There's a command to remove because it's rmrf Andy will remove the whole thing recursively, so it removes the folder and everything in it. I think there's a way to remove a folder only if it's empty. I forget it. But yeah, rm-rf will... Oh, wait, I just figured it out. Make directory Andy. Hold on. I'm just undoing my change. Andy. Yeah, recursive remove. RF just is force. Recursive force. So yeah, it's -r for recursive, meaning remove everything and everything inside it. Sorry for getting confused there. So yeah, that's how you delete. You could delete all the files for the tutorial now if you want to. Finally, there's Rebase. I showed you guys the interactive Rebase, which is the command that modifies other commits. You can also do what's called a Rebase Merge. So I'll just do a quick demo of what that is theoretically. I'll let you guys try it out for yourselves because it's a bit more of an advanced thing. So let's quickly hop this open. No, green, too much green. Make the cursor a bit bigger. So let's say you're working on a project and this is your master branch. And you come and do your own feature branch and do this and this and this. But while you're working on your feature, someone else comes in and adds some commits to the master branch. There's a few ways to deal with this. If you merge, so Git Merge, what that's going to do is it's going to put your commits here, and then it's going to put their commits after, and then it's going to say there's a merge conflict, please fix the merge conflict. And then it's going to make a special merge commit at the end, which fixes all the conflicts. And this merge commit is going to take all the conflicts between your commits and theirs and fix them in one shot. And then once everything's up to date, you can merge that back into master and it will, this is what it looks like after you merge. People don't like this because merge commits are ugly as hell. Like, you can't revert a merge commit because of the nature of how merging works, because of how it's coded. You have a lot of issues that are caused by them. So a lot of people say don't use Git Merge because merge commits are ugly. It's also hard because you have to fix all the conflicts in one shot, which means sometimes you get what I had at CS Games and you spend an hour fixing one merge because you have to fix all the conflicts in one go, which is a huge pain. Instead, what you can do, if I can move this way, is do a Git Rebase. And what Git Rebase does is, I'm actually going to move over to get some more room. This is the master branch. And then instead, it's going to put the other person's commits first. And then it's going to go through your commits one at a time. First, it's going to stick your commit on, and it's going to say, hey, fix the merge conflicts. And then you're going to do that. And then it's going to put your next commit, and it's going to say, fix the merge conflicts. And then you fix them. And then it puts your next commit and says, fix the merge conflicts. And then you fix them. And then once you're done, there's no merge commit, because all of your commits that you made have now been changed to accommodate to what happened in those two here. There's two reasons why this is better. One, you do 3 small merges instead of 1 big merge. 2, there's no ugly ass merge commit that can't be reverted. All of your commits behave as if they were always done on top of this. They're already made to go on top of it. Not only is it not a one-shot mess, but at the end, it's as if you were always working on the same mat, same branch. It's beautiful. Here, it's like, okay, these don't fit at all with these, but then the merge conflict makes everything happy. Instead, at the end, you just have these guys doing their thing, and then your guys, it's like they had always been with them. It's hard to explain, but on the one hand, it's not a one-shot mess. On the other hand, it's cleaner at the end. So I suggest you, this is a bit advanced, and honestly, it took me like years since after I learned Git before I really understood and started using Rebase. So maybe come back to it once you know a bit better, but this is like generally the best practice in the industry. You should be using Rebase instead of Merge. But Merge is simpler, so we start with that. And yeah, that's all the bonus content I have. Just the last bit of advice. in this joke comment is all you have to do is memorize the commands and you're probably going to be fine. If you get trouble, ask someone who knows Git or use the internet. I always forget all the time how to use it, and as a programmer, you'll learn. Just Google it is the answer to 90% of your problems. And if you really mess up your repository, you can always just delete everything, download a fresh copy, and stick your stuff onto it. So thanks a bunch to all of you who are here, who stuck it through it till the end or almost the end. If you have any more questions, feel free to ask. I'll still be here. If you want to ask me like verbally, I can always hop into the SCS Discord after if you want to like ask a couple of things straight to me. Thanks to all of you who participated in the chat too. It's so much more fun and easier to do a workshop when people are messaging in the chat. If you go look at a recording of the last workshop, there was like crickets in the chat, so I'm glad we had a lot of great interaction. It was awesome. Sorry that it went a bit late. I'm having a bit of trouble doing these online. It takes a bit longer. Hopefully you know about SCS if you know about our workshop. If you don't, I'm posting a link in the chat. Hold on. I posted our link tree. I think it messed up the link, so I'll put it here as well. So our link tree is just a special little site that has links to all of our social media. So if you want to follow us on Facebook or join our Discord server or sign up for our newsletter, you'll get all the updates when we have events coming soon. And you can always subscribe to our YouTube channel, which is where we'll upload all of our workshops. Will there be more workshops? 100%. We don't have anything announced yet because we're talking with people and working things out. Everything happens slower because it's online. But I promise you we're having a React workshop coming soon, given by Autodesk. We're going to have a user experience and user interface workshop by Shopify, which should happen soon. But not confirmed because we haven't finalized the details. We might have a workshop by Google about Google Stadia coming soon, so keep an eye out because that might happen soon. Again, we're still in talks. It's not finalized yet. And there's another one coming up soon that I've forgotten about. So definitely keep an eye on our social media where we're going to post about those, and all the recordings will end up on our YouTube channel afterwards. So plenty more workshops to come. We also have algo time if you want to practice your programming every week. It's super fun. And on Monday, we have a CV workshop if you want to work on your CV. Depending where you are in your degree, it might be a bit early for that, but we'll be having a little roast and toast if you want to look at some good CVs and get some advice on your CV. Thank you so much for saying thank you for the workshop. I'm so happy that this was useful to you guys. Hold on to these slides. You can always come look at them later if you need to double check some stuff. 100% recommend you keep messing around with Git. Is algo time beginner friendly? Yes, I did it as a first year. Lots of people do it as first years. If you're a total beginner, it's going to be a bit rough. You're going to have to do a lot of Googling on your own, but we're there to help you. You should definitely, if you want to do it, you should join our Discord, and we have an algo time channel. If you want to like post questions or ask for advice, we're always ready to help beginners because that's kind of why we do this. We love teaching people and we love helping you guys develop a passion for programming. I want to say thank you to you guys directly by name, but I don't want to mispronounce your names, so trust me, I've read all of your thanks in the chat, and I really appreciate it. If you have any more questions, you can ask them now. Otherwise, I'll log off for the evening. All right, that's going to be it for me then. Thanks again to everyone who came to the workshop, and keep an eye out